The universe stretches out in every direction, a boundless expanse filled with mysteries we've only begun to uncover. For centuries, humanity has gazed at the stars, dreaming of what lies beyond our tiny corner of the cosmos. But what if I told you that the answers to some of our most profound questions, like whether we're alone in the universe, or what lies beyond the edges of our solar system, are hidden within what we call the 30 cosmic frontiers of space exploration? These frontiers are more than just distant points of light. They're gateways to understanding our place in the grand tapestry of existence. Today, we're embarking on a journey through these awe-inspiring frontiers, each one a story of discovery, wonder, and possibility. From the enigmatic forces shaping galaxies to the search for life beyond Earth, this exploration will challenge what you think you know about the universe, and maybe even about yourself. So, are you ready to dive into the unknown? Let's begin. Beyond the familiar orbits of Neptune and Pluto lies a realm so distant and faint that it defies easy comprehension: the Oort Cloud. This vast, spherical shell of icy objects marks the outermost edge of our solar system, a frontier so remote that it takes light over a year to travel from here to Earth. Imagine a treasure trove of ancient relics, frozen in time, drifting in the dark. The Oort Cloud is believed to be home to trillions of icy bodies, some as small as pebbles, others as large as mountains, each holding clues to the solar system's earliest days. This mysterious region serves as a cosmic reservoir for long-period comets, those rare, glowing visitors that occasionally streak through our skies. When one of these icy bodies is nudged out of its orbit, perhaps by a passing star or the gravitational tug of the Milky Way itself, it begins a journey that can last thousands or even millions of years before it graces our night sky. But the Oort Cloud is more than just a cosmic deep freeze. It's a time capsule. The icy remnants here are thought to have formed alongside the planets, preserving the raw materials of the solar system in their pristine state. Yet, despite its importance, the Oort Cloud remains one of the least understood regions of our cosmic neighborhood, its sheer distance extending up to a mind-boggling 100,000 times farther from the Sun than Earth makes it nearly impossible to observe directly. Even our most advanced telescopes struggle to pierce the darkness, and no spacecraft has ever come close to reaching it. The Voyager probes, now hurtling through interstellar space, won't enter the Oort Cloud for another 300 years, and even then, they'll only skim its outermost edges. Theories about how the Oort Cloud formed are as fascinating as they are varied. Some scientists suggest it's the leftover debris from the solar system's birth, flung outward by the gravitational chaos of the young planets. Others propose that it could contain material captured from passing stars, a cosmic mixing pot of ancient ingredients. Whatever the truth, the Oort Cloud challenges our understanding of how planetary systems evolve and what lies beyond the boundaries we've mapped. As we peer into the void, the Oort Cloud reminds us of just how vast and uncharted our solar system truly is. But beyond this icy frontier, another boundary awaits, one that stretches even further into the unknown, where the influence of our sun fades and the mysteries of interstellar space begin. As we leave the icy fringes of the Oort Cloud behind, we enter a realm that feels almost otherworldly: interstellar space. This is the vast, nearly empty expanse that stretches between stars, where the influence of our sun fades and the true scale of the cosmos becomes undeniable. Unlike the structured orbits of planets or the icy debris fields of the Oort Cloud, interstellar space is a domain of near-perfect silence and darkness, punctuated only by the faint glow of distant stars and the occasional whisper of cosmic particles. It's here, in this seemingly desolate void, that humanity has taken its first tentative steps beyond the solar system. The Voyager probes, launched in the late 1970s, have become our interstellar pioneers. These robotic explorers, now billions of miles from Earth, carry with them golden records filled with sounds and images of our world, a message to any potential listeners in the cosmos. But more importantly, they've sent back groundbreaking data, revealing the secrets of this uncharted frontier. One of the most surprising discoveries from Voyager's journey is the presence of interstellar dust-tiny particles drifting through the void. These grains, though minuscule, tell a story of the universe's history, carrying traces of ancient supernova and the building blocks of planets. Voyager has also detected magnetic fields in interstellar space, far weaker than those near the Sun, but still shaping the flow of cosmic particles. These findings challenge our assumptions about the emptiness of space, showing that even in the void, there's a subtle, intricate dance of forces at work. Yet, studying interstellar space is no easy feat. The distances are staggering so vast that even light takes years to traverse them. Without the sun's warmth or light, spacecraft must rely on nuclear power to keep their instruments running. And then there's the challenge of communication. Sending a signal from Voyager takes over 20 hours to reach Earth, and the data it sends back is faint, like a whisper in a hurricane. Despite these hurdles, the exploration of interstellar space holds immense promise. It's a frontier where we might uncover entirely new phenomena, from exotic particles to clues about the origins of the universe itself. And as we push further into this uncharted territory, we're reminded of how much we still have to learn about the cosmos. But interstellar space isn't the end of the journey. It's a gateway to even greater mysteries. Beyond the void lies the next frontier, the search for habitable worlds, places where life might exist beyond our solar system. Could there be planets out there, orbiting distant stars, with conditions ripe for life? The answers may lie closer than we think. The search for exoplanets, worlds orbiting stars beyond our solar system, has opened up a thrilling new chapter in our exploration of the cosmos. Just a few decades ago, the idea of discovering planets around distant stars was the stuff of science fiction. Today, thanks to groundbreaking missions like Kepler and TESS, we've confirmed the existence of over 5,000 exoplanets, with thousands more waiting to be verified. These discoveries have transformed our understanding of the universe, revealing a stunning diversity of worlds that challenge our imagination. From scorching hot gas giants that orbit their stars in a matter of days to rocky super-Earths with surfaces that might resemble our own, exoplanets come in every conceivable form. Some are so dense they're made almost entirely of diamond, while others are so light they could float on water. And then there are the most tantalizing of all, Earth-like planets nestled in their star's habitable zone, where conditions might be just right for liquid water and perhaps life to exist. The Kepler mission, launched in 2009, was the first to systematically hunt for these distant worlds. By staring at a single patch of sky for years, it detected the faint dimming of starlight as planets passed in front of their host stars. This technique, known as the transit method, has become a cornerstone of exoplanet discovery. More recently, TESS, the Transiting Exoplanet Survey satellite, has taken up the mantle, scanning the entire sky for nearby stars and their planetary companions. Together, these missions have painted a picture of a galaxy teeming with planets, each one a potential window into the origins of life. The diversity of exoplanets has forced us to rethink what makes a planet habitable. Take Proxima Centauri b, for example, a rocky world just 4.2 light-years away. It orbits within the habitable zone of its star, but its proximity raises questions about the stability of its atmosphere and the intensity of radiation it might endure. Then there's the TRAPPIST-1 system, home to 7 Earth-sized planets, 3 of which lie in the habitable zone. Could one of these worlds host oceans or even life? The possibilities are as endless as they are exciting, but the search for exoplanets isn't just about finding potential homes for life. It's about understanding the universe itself. Each discovery adds a piece to the puzzle of how planetary systems form and evolve. Some exoplanets orbit binary stars, creating landscapes straight out of Star Wars. Others are rogue planets, drifting through space without a star to call home. These findings remind us that the cosmos is far stranger and more varied than we ever imagined. As we continue to explore this frontier, the implications for finding extraterrestrial life grow ever more profound. Every new exoplanet brings us closer to answering one of humanity's oldest questions: are we alone? But the journey doesn't stop here. Beyond the realm of exoplanets lies another frontier, one that takes us closer to the heart of the galaxy, the stars themselves. What secrets do they hold, and how do they shape the worlds that orbit them? The answers await us in the next chapter of this cosmic adventure. As we move deeper into the heart of the galaxy, we encounter a phenomenon that's both breathtaking and fundamental to the story of the cosmos stellar nurseries. These vast, swirling clouds of gas and dust are the birthplaces of stars, cosmic cradles where the raw materials of the universe come together to ignite the light that fills the night sky. Imagine a place where gravity weaves its magic, pulling together particles so tenuous that, in most of space, they drift apart. Yet here, in these dense, dark clouds, they coalesce into the dazzling stars that define galaxies. One of the most famous stellar nurseries is the Orion Nebula, a glowing tapestry of gas and dust visible even to the naked eye. Located about 1,300 light-years from Earth, this nebula is a bustling factory of star formation. Within its depths, gravity works tirelessly, compressing pockets of gas until they reach the critical point where nuclear fusion ignites. When that happens, a new star is born, bursting into life and illuminating the surrounding cloud with its light. But the story doesn't end there. As stars form, they often leave behind swirling disks of leftover material debris that can eventually clump together to form planets, moons, and asteroids. In this way, stellar nurseries are not just the birthplaces of stars, but also the seeds of entire planetary systems. The Orion Nebula, for instance, is home to hundreds of young stars, many of which are surrounded by these protoplanetary disks. It's a reminder that the formation of our own solar system likely began in a place much like this, over 4.5 billion years ago. Studying stellar nurseries isn't just about understanding how stars are born, it's about piecing together the cosmic puzzle of how everything in the universe came to be. By observing these regions with telescopes like Hubble and the James Webb Space Telescope, scientists have uncovered the intricate processes that govern star formation. They've seen how shockwaves from nearby supernovae can trigger the collapse of gas clouds, sparking new waves of star birth. They've also discovered that these nurseries are not uniform. Some regions produce massive stars that burn bright and die young, while others give rise to smaller, longer-lived stars like our Sun. The beauty of stellar nurseries lies in their complexity and dynamism. They are places of constant change where chaos and creation coexist. One moment, a cloud of gas might appear still and lifeless. The next, it could be teeming with newborn stars, their light cutting through the darkness. It's a reminder that the universe is always in motion, always evolving. As we marvel at the wonders of stellar nurseries, we're reminded that every star we see in the night sky has its own origin story, born from the same cosmic processes that shaped our own sun. But stars, like all things, have their own life cycles, stages of existence that take them from birth to death and beyond. And it's in the next frontier that we'll explore these stages, uncovering the dramatic and often beautiful transformations that stars undergo as they age. Stars are born in the brilliance of stellar nurseries, but their deaths are no less spectacular and far more explosive. For massive stars, the end comes not with a whimper, but with a cataclysmic bang, a supernova. These titanic explosions are among the most powerful events in the universe, capable of outshining entire galaxies for a brief moment. But a supernova is more than just a cosmic fireworks display. It's a transformative event that reshapes the fabric of space itself. Imagine a star, many times more massive than our sun, reaching the end of its life. After burning through its nuclear fuel, it can no longer withstand the crushing force of its own gravity. The core collapses in on itself, triggering a shockwave that rips through the star's outer layers. In an instant, the star explodes, releasing an unimaginable amount of energy. This is a supernova, a burst so bright it can be seen across billions of light years. But the true significance of supernova lies in what they leave behind. During the explosion, the intense heat and pressure forge heavy elements like gold, silver, and uranium, elements that were once thought to form only in the hearts of stars. These materials are then scattered across the cosmos, seeding the interstellar medium with the building blocks of planets, moons, and even life itself. Every atom of iron in your blood, every speck of calcium in your bones, was forged in the fiery heart of a dying star. Supernova also play a crucial role in shaping galaxies. The shockwaves from these explosions can compress nearby gas clouds, triggering the formation of new stars and planetary systems. In this way, the death of one star becomes the birth of countless others, a cosmic cycle of creation and destruction that has been repeating for billions of years. Studying supernova has given scientists invaluable insights into the life cycles of stars and the evolution of the universe. Modern telescopes allow us to observe these events in real time, capturing the moment a star explodes and tracking the aftermath as its light fades. These observations help us understand the physics of extreme environments, from the collapse of stellar cores to the behavior of matter under conditions we could never replicate on Earth. One of the most famous supernova in history, SN 1987A, occurred in the Large Magellanic Cloud, a neighboring galaxy. Its light reached Earth in 1987, offering astronomers a front-row seat to one of the universe's most dramatic events. From that explosion, we learned about the formation of neutron stars, the remnants of supernova that are so dense a teaspoon of their material would weigh billions of tons. As awe-inspiring as supernova are, their aftermath holds its own mysteries. The remnants of these explosions, expanding clouds of gas and dust, continue to shape the cosmos long after the initial burst of light has faded. These remnants, rich in heavy elements, serve as the raw materials for future generations of stars and planets. But what happens to the core of the star after the explosion? That question leads us to the next frontier, where we'll explore the strange and fascinating remnants of stellar death objects like neutron stars and black holes, whose extreme properties defy our understanding of physics. These remnants are not just the end of a star's life, they're the beginning of a new chapter in the story of the universe. When a massive star explodes in a supernova, it doesn't just vanish, it leaves behind something extraordinary. At the heart of that explosion lies one of the most bizarre and fascinating objects in the universe, a neutron star. Imagine compressing the mass of our Sun into a sphere no wider than a city. The result is a neutron star, an object so dense that a single sugar cube-sized piece would weigh 1 billion tons on Earth. These cosmic remnants are not just remnants of stellar death, they're extreme laboratories where the laws of physics are pushed to their limits. Neutron stars are born from the collapse of a massive star's core. As gravity crushes the core down to unimaginable densities, protons and electrons merge to form neutrons, creating a material unlike anything found on Earth. But the strangeness doesn't stop there. Many neutron stars spin at mind-bending speeds, completing hundreds of rotations every second. This rapid spin, combined with their intense magnetic fields, can produce beams of radiation that sweep across the cosmos like a lighthouse. When these beams point toward Earth, we detect them as pulsars, blinking cosmic beacons that pulse with remarkable precision. The first pulsar was discovered in 1967, and its regular flashes of radio waves were so precise that astronomers initially nicknamed it LGM-1, short for Little Green Men. While it turned out not to be a signal from aliens, pulsars have proven to be just as intriguing. Their precision makes them cosmic clocks, helping scientists test theories of gravity and space-time. For instance, the study of binary pulsars, pairs of neutron stars orbiting each other, provided the first indirect evidence of gravitational waves, ripples in space-time predicted by Einstein over a century ago. But the story of neutron stars doesn't end with their discovery. In 2017, a groundbreaking event occurred. The collision of two neutron stars was detected not only through gravitational waves, but also through light. This historic observation, made by the LIGO and Virgo observatories, marked the dawn of multi-messenger astronomy. For the first time, scientists could study the same cosmic event using both gravitational waves and electromagnetic radiation, opening a new window into the universe. Neutron stars are also cosmic alchemists. When two of them collide, the immense pressure and heat forge heavy elements like gold, platinum, and uranium, scattering them across the cosmos. The gold in your jewelry or the uranium used in power plants likely originated in such a cataclysmic event billions of years ago. In this way, neutron stars are not just remnants of the past, they're creators of the future, seeding the universe with the materials needed for planets and perhaps life to form. As we peer deeper into the mysteries of neutron stars, we're reminded of how much we still have to learn about the extremes of the universe. These objects challenge our understanding of matter, gravity, and even time itself. But beyond neutron stars lies an even more enigmatic frontier, one where gravity becomes so intense that not even light can escape. This is the realm of black holes, where the rules of physics as we know them may no longer apply. What secrets do these cosmic shadows hold, and how do they shape the universe around them? The answers await us in the next chapter of this cosmic journey. Black holes are perhaps the most mysterious and awe-inspiring objects in the universe regions of spacetime, where gravity is so intense that not even light can escape. Imagine a place where the laws of physics as we know them break down, where time slows to a crawl, and where the very fabric of reality is warped beyond recognition. These cosmic enigmas are born from the death throes of massive stars, collapsing under their own gravity into an infinitely dense point called a singularity. But black holes are far more than just cosmic vacuum cleaners. They are gateways to understanding the extremes of the universe. There are several types of black holes, each with its own fascinating characteristics. Stellar mass black holes form when a massive star exhausts its nuclear fuel and collapses, resulting in an object just a few times more massive than our Sun. Supermassive black holes, on the other hand, are millions or even billions of times more massive, lurking at the centers of galaxies like our own Milky Way. How these giants form remains a mystery, but their influence on the cosmos is undeniable. They shape the structure of galaxies, driving the motion of stars and gas around them, and sometimes even triggering the birth of new stars in their wake. One of the most groundbreaking moments in black hole research came in April 2019, when the Event Horizon Telescope collaboration unveiled the first ever image of a black hole. This stunning picture, captured using a global network of radio telescopes, showed the shadow of the supermassive black hole at the center of the galaxy M87, 55 million light-years away. The image revealed a glowing ring of light encircling the black hole's event horizon, the point of no return where gravity's grip becomes inescapable. This achievement was not just a triumph of technology, but a profound reminder of humanity's ability to explore the most distant and mysterious corners of the universe. Black holes also play a crucial role in the formation and evolution of galaxies. The supermassive black holes at their centers act as cosmic engines, drawing in vast amounts of matter and releasing enormous amounts of energy in the process. This energy can heat up surrounding gas, preventing it from collapsing into stars and regulating the growth of the galaxy itself. In some cases, black holes even collide, sending ripples through spacetime known as gravitational waves, a phenomenon first detected in 2015 by the LIGO observatories. But the mysteries of black holes don't end there. Some theories suggest they could be portals to other dimensions or universes, offering a tantalizing glimpse into the unknown. While these ideas remain speculative, they highlight the profound questions black holes raise about the nature of space, time, and reality itself. As we peer into the depths of these cosmic shadows, we're reminded of how much we still have to learn. Black holes challenge our understanding of the universe, pushing the boundaries of science and imagination, but they are just one piece of a much larger puzzle, a puzzle that includes the galaxies they inhabit. These vast collections of stars, gas, and dust are the building blocks of the cosmos, each one a unique tapestry of light and shadow, and it's in the next frontier that will explore the structure and diversity of galaxies, uncovering the stories they tell about the universe's past, present, and future. At the heart of every galaxy lies a place of unimaginable power and mystery, the Galactic Center. This is the cosmic core, a region where gravity reigns supreme and the laws of physics are pushed to their limits. In the case of our own Milky Way, this center is home to a supermassive black hole known as Sagittarius, a star, an object 4 million times more massive than our Sun. But the Galactic Center is far more than just a black hole's domain. It's a bustling hub of activity, where stars orbit at breathtaking speeds, gas clouds collide, and energy is unleashed on a scale that defies comprehension. The environment around a supermassive black hole is unlike anything else in the universe. Intense gravitational forces stretch and twist spacetime, creating conditions so extreme that they warp the very fabric of reality. Stars in this region can reach speeds of thousands of kilometers per second, hurtling around the black hole in tight, elliptical orbits. Some of these stars are so close that they're torn apart by tidal forces, their material spiraling into the black hole in a brilliant display of light and energy. This process, known as accretion, creates some of the brightest and most energetic phenomena in the cosmos, from X-ray bursts to powerful jets of particles that shoot out at nearly the speed of light. Telescopes like Chandra and Hubble have given us unprecedented views of these dynamic regions. Chandra, which observes the universe in X-rays, has revealed the intense heat and radiation emitted by gas as it falls into the black hole. Hubble, with its sharp optical vision, has captured stunning images of stars whirling around the galactic center, their paths tracing the invisible pull of gravity. Together, these observations have painted a vivid picture of the chaos and beauty that define galactic centers. But why do these regions matter? Beyond their sheer spectacle, galactic centers hold the key to understanding how galaxies form and evolve. Supermassive black holes, despite their destructive reputation, play a crucial role in shaping their host galaxies. The energy they release during accretion can heat up surrounding gas, preventing it from collapsing into new stars and regulating the growth of the galaxy. In some cases, the jets they emit can even trigger star formation in distant regions, creating a delicate balance between creation and destruction. Our own galactic center offers a unique laboratory for studying these processes. Located about 26,000 light-years from Earth, Sagittarius, a star, is relatively quiet compared to some of its more active counterparts in other galaxies. This makes it an ideal target for observation, allowing scientists to study the intricate dance of stars and gas around a supermassive black hole in detail. Recent discoveries, such as the detection of strange radio filaments and mysterious objects orbiting the black hole, have only deepened the intrigue surrounding this region. As we peer into the heart of the Milky Way, we're reminded of how interconnected the cosmos truly is. The forces at work in galactic centers shape the fate of entire galaxies, influencing everything from star formation to the distribution of matter. And while much remains to be discovered, one thing is clear: these regions are not just the end of our journey, they are the beginning of a deeper exploration into the larger structures of the universe. From galactic cores, we'll turn our gaze outward to the vast web of galaxies that stretches across the cosmos. What secrets lie hidden in this cosmic tapestry, and how do these structures shape the universe we know today? The answers await us in the next frontier. Beyond the swirling cores of individual galaxies lies an even grander scale of cosmic structure: galaxy clusters and superclusters. These sprawling collections of galaxies, bound together by gravity, represent the largest organized systems in the universe. Imagine a city of stars, where hundreds or even thousands of galaxies orbit one another, their collective mass creating a gravitational anchor that shapes the cosmos around them. But galaxy clusters are more than just cosmic cities. They are the building blocks of the universe's vast architecture, offering clues to the forces that govern everything we see and much of what we don't. Galaxy clusters are immense. A single cluster can contain hundreds of galaxies, trillions of stars, and vast clouds of hot gas, all held together by gravity's invisible grip. The gas within these clusters, heated to millions of degrees, glows brightly in X-rays, revealing the cluster's structure and dynamics. Some clusters, like the famous Virgo cluster, are relatively close to us, while others lie billions of light-years away, their light offering a glimpse into the universe's distant past. Superclusters take this scale even further. These are groupings of galaxy clusters, forming immense filaments that stretch across the cosmos. Together, they weave the cosmic web, a vast, interconnected network of matter that defines the large-scale structure of the universe. The Milky Way, for example, resides in the Laniakea supercluster, a structure so large that it spans 500 million light-years and contains over 100,000 galaxies. Studying these colossal structures is no small feat. Mapping galaxy clusters and superclusters requires observing vast swaths of the sky, often using multiple telescopes to capture different wavelengths of light. Projects like the Sloan Digital Sky Survey have created detailed 3D maps of the universe, revealing the intricate patterns of the cosmic web. These maps show how matter is distributed across the universe, with clusters and superclusters forming dense knots in the web, connected by long, thin filaments of galaxies and gas. One of the most fascinating aspects of galaxy clusters is their role in uncovering the universe's hidden secrets. The immense gravitational pull of clusters bends light from objects behind them, a phenomenon known as gravitational lensing. This effect not only magnifies distant galaxies, but also allows scientists to map the distribution of dark matter, the mysterious substance that makes up most of the universe's mass. By studying how light bends around clusters, researchers can infer the presence and behavior of this invisible material. Galaxy clusters also provide insights into dark energy, the enigmatic force driving the universe's accelerated expansion. By measuring the distances and velocities of clusters, scientists can trace how the universe has expanded over time, revealing the influence of dark energy on the cosmos. These observations have led to some of the most profound discoveries in modern cosmology, reshaping our understanding of the universe's fate. As we explore these vast structures, we're reminded of how interconnected the universe truly is. Galaxy clusters and superclusters are not just isolated islands of matter. They are part of a grand cosmic dance, shaped by the interplay of gravity, dark matter, and dark energy. Yet, even as we uncover the secrets of these immense formations, we're faced with new questions about the invisible forces that govern them. What is the true nature of dark matter and dark energy, and how do they shape the universe on the largest scales? These mysteries lead us to the next frontier, where we'll delve into the unseen forces that hold the cosmos together and drive it apart. As we unravel the vast structures of galaxy clusters and superclusters, we encounter a mystery that lies at the very foundation of the cosmos: dark matter. This invisible substance makes up about 85% of all matter in the universe, yet it remains one of the most elusive and enigmatic phenomena scientists have ever studied. Unlike the stars, gas, and dust we can see, dark matter doesn't emit, absorb, or reflect light. It doesn't interact with electromagnetic forces at all. So, how do we know it's there? The answer lies in the subtle but unmistakable fingerprints it leaves on the universe around us. One of the most compelling pieces of evidence for dark matter comes from the way galaxies rotate. When astronomers first measured the speeds of stars and gas within spiral galaxies, they expected the outer regions to move slower than the inner ones, much like planets farther from the Sun orbit more slowly. But what they found was astonishing. Stars in the outer reaches of galaxies were moving just as fast as those near the center. This suggested that there must be far more mass in these galaxies than what was visible, mass that we now attribute to dark matter. Without its gravitational pull, galaxies would simply fly apart. Another key clue comes from gravitational lensing, a phenomenon where the gravity of massive objects, like galaxy clusters, bends the light from objects behind them. By studying how this light is distorted, scientists can map the distribution of mass in the cluster. Time and again, these maps reveal that the visible matter, stars, gas, and dust, accounts for only a fraction of the total mass. The rest is dark matter, an invisible scaffold that shapes the cosmos on the largest scales. Despite its pervasive influence, dark matter has yet to be directly detected. Scientists have proposed a variety of candidates for what it might be, from weakly interacting massive particles, or WIMP, to actions hypothetical particles that could solve multiple cosmic puzzles. Experiments around the world, from deep underground detectors to space-based observatories, are searching for signs of these elusive particles. But so far, dark matter has remained frustratingly out of reach, leaving us with more questions than answers. The implications of solving the dark matter mystery are profound. Understanding this hidden substance could reveal new physics beyond the standard model, the framework that describes the fundamental particles and forces of the universe. It could also shed light on the formation of galaxies, the evolution of the cosmos, and even the ultimate fate of the universe. Yet, for all we've learned, dark matter continues to defy explanation, reminding us of how much we still have to discover. But dark matter isn't the only invisible force shaping the universe. Beyond its shadow lies an even more mysterious phenomenon, dark energy, a force that's driving the accelerated expansion of the cosmos. This discovery, made just over 2 decades ago, has fundamentally changed our understanding of the universe, raising questions that are as profound as they are perplexing. What is dark energy, and how does it work? The answers may lie in the next frontier of our cosmic journey. If dark matter is the unseen scaffold holding galaxies together, then dark energy is the mysterious force pushing the cosmos apart. This enigmatic phenomenon, first discovered in the late 1990s, has completely reshaped our understanding of the universe. Unlike gravity, which pulls matter together, dark energy acts as a kind of anti-gravity, driving the accelerated expansion of the universe. It's as if the cosmos is stretching itself out faster and faster, with dark energy as the invisible hand behind it all. But what exactly is this force, and how does it work? The answers remain as elusive as the phenomenon itself. The discovery of dark energy came as a shock to scientists. In the late 1990s, 2 independent teams of astronomers were studying distant supernova exploding stars that serve as cosmic mile markers. By measuring how bright these supernovae appeared, they hoped to calculate how fast the universe was expanding. To their surprise, they found that the light from these supernovae was dimmer than expected, suggesting that the universe wasn't just expanding, it was doing so at an accelerating rate. This revelation earned the teams the Nobel Prize in Physics in 2011 and opened up a new frontier in cosmology. So, what could be causing this acceleration? One leading theory is that dark energy is a property of space itself, often referred to as the cosmological constant. Proposed by Einstein over a century ago, the cosmological constant was originally introduced as a way to balance the equations of general relativity and maintain a static universe. Einstein later dismissed it as his greatest blunder, but modern observations suggest it might be the key to understanding dark energy. If space itself has an intrinsic energy density, it could explain why the universe is expanding faster over time. Another possibility is that dark energy is a dynamic field, similar to the Higgs field that gives particles mass. This field, sometimes called quintessence, could change over time, potentially altering the rate of cosmic expansion. If true, it would mean that dark energy isn't constant but evolves alongside the universe. The implications of dark energy are profound. If the universe continues to expand at an accelerating rate, it could lead to a big freeze, where galaxies drift so far apart that the cosmos becomes a cold, dark, and empty void. Alternatively, if dark energy strengthens over time, It could tear apart galaxies, stars, and even atoms in a catastrophic event known as the Big Rip. These scenarios highlight just how much is at stake in understanding this mysterious force. Studying dark energy is no easy task. Unlike dark matter, which exerts a gravitational pull we can measure, dark energy leaves no direct traces. Instead, scientists rely on indirect methods, such as mapping the distribution of galaxies, measuring the cosmic microwave background, and observing gravitational lensing. Projects like the Dark Energy Survey and the upcoming Euclid mission aim to shed light on this cosmic mystery, using cutting-edge technology to probe the universe's expansion in unprecedented detail. As we grapple with the nature of dark energy, we're reminded of how much we still don't know about the universe. This force, which makes up about 68% of the cosmos, is one of the greatest puzzles in modern science. Yet, even as we seek to unravel its secrets, another frontier beckons, one that takes us back to the very beginning of the universe itself. What can the early universe tell us about the origins of everything we see today? The answers lie in the next chapter of this cosmic journey. To understand the origins of the universe, we must look back in time, not just millions, but billions of years. And surprisingly, one of the most powerful tools for this journey is something we encounter every day, though we rarely notice it: heat. Not the warmth of the sun or the glow of a fire, but a faint, almost imperceptible heat that permeates the entire cosmos. This is the cosmic microwave background, or CMB, often described as the afterglow of the Big Bang. It's a relic from the earliest moments of the universe, a whisper from a time when everything we know was compressed into a single, unimaginably dense point. The CMB is like a cosmic photograph, capturing the universe just 380,000 years after the Big Bang. Before this moment, the universe was a seething, opaque soup of particles and energy, too hot and dense for light to travel freely. But as the cosmos expanded and cooled, electrons and protons combined to form neutral atoms, allowing light to break free and stream across space. That light, stretched and cooled by the universe's expansion over the past 13.8 billion years, is what we now detect as the CMB. The discovery of the CMB in 1965 was a turning point in cosmology. Two radio astronomers, Arno Penzias and Robert Wilson, stumbled upon a persistent static noise while testing a sensitive antenna. At first, they thought it was interference, perhaps from pigeon droppings on their equipment, but after ruling out every possible source, they realized they had found something extraordinary: the faint echo of the Big Bang itself. This discovery earned them a Nobel Prize and provided the first direct evidence for the Big Bang theory, reshaping our understanding of the universe's origins. Since then, missions like COBE, WMAP, and Planck have taken the study of the CMB to extraordinary new heights. COBE, launched in 1989, made the first precise measurements of the CMB, revealing tiny temperature fluctuations that hinted at the seeds of cosmic structure. WMAP, which followed in 2001, mapped these fluctuations in greater detail, providing a sharper picture of the early universe. And Planck, launched in 2009, delivered the most detailed map yet, with precision so fine it's often compared to measuring the thickness of a hair from a kilometer away. These missions have revealed astonishing insights. The CMB's temperature fluctuations, though minuscule, are the blueprints for everything we see today: galaxies, stars, and even planets like Earth. They tell us about the universe's composition, its rate of expansion, and even the nature of dark matter and dark energy. The CMB also provides a window into the universe's infancy, offering clues about its earliest moments, such as the period of rapid expansion known as inflation. But the CMB is more than just a snapshot of the past. It's a living record of the universe's history. By studying its patterns, scientists have pieced together a timeline of cosmic evolution, from the first particles to the formation of galaxies. It's a story that connects us all, tracing the origins of every atom in our bodies back to the fiery birth of the universe. As we marvel at the insights gained from the CMB, we're reminded of how far we've come in unraveling the mysteries of the cosmos. Yet, the CMB also raises profound questions about what came before it. What triggered the Big Bang? What existed before the universe as we know it began? These questions lead us to the next frontier, where we'll explore the origins of the universe itself, a journey that takes us to the very edge of scientific understanding. The Big Bang theory stands as one of the most profound and well-supported ideas in all of science, a story that begins with the birth of the universe itself. Imagine a moment, roughly 13.8 billion years ago, when all of space, time, matter, and energy were compressed into an infinitely small, infinitely dense point. Then, in a fraction of a second, this point exploded outward, setting the stage for everything we see today. The Big Bang wasn't an explosion in space. It was the explosion of space, the rapid expansion of the universe from a single, unimaginable origin. The evidence supporting the Big Bang is as compelling as it is diverse. One of the most striking pieces of evidence comes from the expansion of the universe itself. In the early 20th century, astronomer Edwin Hubble observed that distant galaxies were moving away from us, their light stretched into longer, redder wavelengths, a phenomenon known as redshift. This discovery led to the realization that the universe isn't static, it's expanding. If we rewind that expansion, we're led back to a single point in time and space, the Big Bang. Another key piece of evidence lies in the abundance of light elements, particularly hydrogen and helium. According to the Big Bang theory, within the first few minutes after the initial expansion, the universe was hot and dense enough for nuclear fusion to occur. This process forged the simplest elements, with hydrogen making up about 75% of the universe's matter and helium around 25%. The precise ratios of these elements, predicted by the theory, match what we observe today, offering a powerful confirmation of the Big Bang's validity. Yet, for all its explanatory power, the Big Bang theory leaves some of the most profound questions unanswered. What triggered the Big Bang? What existed before it? These questions push the boundaries of our understanding, challenging us to think beyond the limits of current physics. Some theories suggest that the Big Bang wasn't a singular event, but rather a phase in a much larger cosmic cycle, perhaps part of an endless series of expansions and contractions. Others propose that our universe is just one of countless others, part of a vast multiverse where Big Bangs happen all the time. These ideas aren't just speculative, they're grounded in the same curiosity and rigor that led to the discovery of the Big Bang itself. For instance, the concept of cosmic inflation, a rapid expansion of the universe in the moments after the Big Bang, helps explain why the universe appears so uniform on large scales. But inflation also opens the door to the multiverse hypothesis, suggesting that our universe might be just one bubble in a frothy sea of universes, each with its own unique laws of physics. As we grapple with these questions, we're reminded that the Big Bang isn't just a theory about the past, it's a window into the future of cosmology. It challenges us to rethink our place in the cosmos, to consider the possibility that our universe is just one piece of a much larger puzzle. This brings us to the next frontier, where we'll explore one of the most intriguing and controversial ideas in modern science, the multiverse. Could there be other universes beyond our own, each with its own story, its own laws, and perhaps even its own versions of us? The answers may lie in the uncharted territory of the multiverse, a concept that stretches the limits of imagination and redefines what it means to explore the cosmos. What if our universe isn't the only one? What if, beyond the stars and galaxies we see, there are countless other universes, each with its own laws of physics, its own histories, and perhaps even its own versions of us? This is the tantalizing idea behind the multiverse, a concept that stretches the boundaries of science and imagination. While it may sound like science fiction, the multiverse is a serious topic of discussion among physicists, rooted in some of the most profound theories of modern cosmology. One of the leading ideas supporting the multiverse is eternal inflation. According to this theory, the rapid expansion of the early universe, known as cosmic inflation, didn't happen just once. Instead, it's a continuous process, creating countless bubble universes that pop into existence, each with its own unique properties. Imagine a cosmic foam where every bubble is a separate universe, expanding and evolving on its own. Some of these universes might be similar to ours, while others could be wildly different, governed by laws of physics we can't even imagine. String theory, another cornerstone of modern physics, also points to the possibility of a multiverse. This theory suggests that the fundamental building blocks of the universe are tiny, vibrating strings, and the way they vibrate determines the properties of particles and forces. But string theory also predicts the existence of extra dimensions, up to 10 or 11 in some versions. In this framework, our universe could be just one of many, each occupying a different slice of these higher dimensional space. The implications of the multiverse are staggering. If true, it would mean that every possible outcome of every possible event has happened somewhere in the vast tapestry of parallel universes. It would redefine our understanding of reality, suggesting that our universe is just one thread in an infinite cosmic fabric. Yet, for all its grandeur, the multiverse remains one of the most challenging ideas to test. How do we detect something that, by definition, exists beyond the reach of our universe? Some scientists have proposed indirect methods, such as looking for evidence of collisions between our universe and others. These collisions might leave faint imprints in the cosmic microwave background, the afterglow of the Big Bang. Others suggest that the distribution of dark energy or the behavior of black holes could hint at the existence of parallel universes. But for now, the multiverse remains a tantalizing possibility, a frontier where science and speculation meet in the search for answers. As we explore the multiverse, we're reminded of how much we still have to learn about the cosmos. This idea challenges us to think beyond the limits of our own universe, to imagine realities that might exist just beyond our reach. But while the multiverse stretches our imagination, the next frontier brings us closer to home, or at least closer to the possibility of neighbors. What if we're not alone in the universe? What if life exists beyond Earth, waiting to be discovered? The search for extraterrestrial life is a journey that could change everything we know about our place in the cosmos. The search for extraterrestrial life is one of the most profound and captivating quests in all of science. Are we alone in the universe, or is life out there, waiting to be discovered? This question has driven humanity to look beyond our planet, exploring the cosmos for signs of life. Whether it's a single-celled organism on a distant moon or an advanced civilization sending signals across the stars. The search is not just about finding answers, It's about redefining our place in the universe. One of the most promising avenues in this search is the hunt for biosignatures, chemical or physical markers that could indicate the presence of life. On exoplanets, scientists look for gases like oxygen, methane, or ozone in the atmosphere, which could be produced by living organisms. Telescopes like the James Webb Space Telescope are designed to analyze the atmospheres of distant worlds, searching for these telltale signs. Already, planets like those in the TRAPPIST-1 system have sparked excitement, with their potential for liquid water and Earth-like conditions. Closer to home, our own solar system holds tantalizing possibilities. Mars, with its ancient riverbeds and subsurface ice, has long been a target in the search for microbial life. Missions like NASA Perseverance rover are actively drilling into Martian soil, collecting samples that may one day reveal evidence of past or present life. Meanwhile, Europa, one of Jupiter's icy moons, has captured the imagination of scientists. Beneath its frozen surface lies a vast ocean, warmed by the moon's internal heat, a perfect environment for life to thrive. Future missions, like the Europa Clipper, aim to explore this hidden world, searching for signs of habitability. But the search for life isn't limited to microbial organisms. For decades, scientists have also been listening for signals from intelligent civilizations through projects like SETI, the search for extraterrestrial intelligence. Using powerful radio telescopes, they scan the skies for patterns or messages that could indicate the presence of advanced beings. While no definitive signal has been found yet, the sheer vastness of the universe means the possibilities are endless. The implications of discovering extraterrestrial life are staggering. Even finding a single microbe on another world would transform our understanding of biology and our place in the cosmos. It would suggest that life is not a rare, earth-bound phenomenon, but a common feature of the universe. And if we were to detect an intelligent civilization, it would open up entirely new questions about communication, ethics, and our shared existence in the universe. As we continue to explore these possibilities, we're reminded that the search for life is also a search for ourselves, our origins, our uniqueness, and our future. But this quest doesn't end with finding life. It also raises another profound question. Can humanity become a multiplanetary species? The next frontier takes us beyond discovery to the possibility of human colonization, where we might one day call other worlds home. Mars has long captured our imagination as the next great frontier for humanity. Often called the Red Planet, it stands out as the most promising candidate for human colonization in our solar system. Its day is roughly the same length as Earth's, and it has seasons similar to ours, thanks to its tilted axis. But while Mars may seem like a familiar cousin, living there would be anything but easy. The challenges are immense, and overcoming them will require ingenuity, determination, and a willingness to push the boundaries of what's possible. One of the biggest hurdles is Mars' thin atmosphere, which is composed mostly of carbon dioxide and offers little protection from the sun's harmful radiation. Unlike Earth, which has a magnetic field and a thick atmosphere to shield us, Mars exposes its surface to dangerous levels of cosmic rays and solar particles. This means that any long-term human presence would require advanced shielding, whether through habitats built underground or constructed with radiation-resistant materials. Then there's the issue of water. While Mars isn't entirely dry, its polar ice caps and subsurface glaciers hold frozen water. Accessing and utilizing this resource will be a monumental task. Extracting water from the ice or even the thin atmosphere would require cutting-edge technology and a reliable energy source. Without a steady supply of water, growing food, producing oxygen, and sustaining life would be impossible. Despite these challenges, space agencies and private companies are already laying the groundwork for a future on Mars. NASA Artemis program aims to return humans to the Moon as a stepping stone to Mars, testing technologies and life support systems that could be adapted for the Red Planet. SpaceX, led by Elon Musk, has even more ambitious plans, with the goal of sending humans to Mars within the next decade. Their Starship spacecraft, designed for long-duration missions, could one day carry settlers to establish a self-sustaining colony. But colonization isn't just about survival, it's about thriving. Some scientists have proposed the idea of terraforming Mars, transforming its environment to make it more Earth-like. This could involve releasing greenhouse gases to thicken the atmosphere and warm the planet, or even introducing microbes to produce oxygen over time. While these ideas remain speculative, they offer a glimpse into a future where Mars could become a second home for humanity. Creating a sustainable habitat on Mars would also require innovative solutions, from 3D printed structures using Martian soil to closed-loop life support systems that recycle air, water, and waste. These technologies wouldn't just benefit Mars, they could revolutionize how we live on Earth, offering new ways to address resource scarcity and environmental challenges. As we dream of a future on Mars, we're reminded that this frontier is just the beginning. Beyond the Red Planet lies an even greater expanse, filled with worlds that could one day become part of humanity's story. What lies ahead in the outer reaches of our solar system, and how might we explore these distant realms? The answers await us in the next chapter of this cosmic journey. While Mars often takes the spotlight in discussions of human exploration, some of the most intriguing destinations in our solar system aren't planets at all, they are moons. Orbiting the gas giants Jupiter and Saturn, worlds like Europa, Enceladus, and Titan hold secrets that could redefine our understanding of life and habitability. These icy moons, once thought to be barren and lifeless, are now at the forefront of astrobiological research, offering tantalizing hints of subsurface oceans and the potential for microbial life. Europa, one of Jupiter's largest moons, is a prime candidate in the search for extraterrestrial life. Beneath its icy crust lies a global ocean, believed to hold more than twice the volume of all Earth's oceans combined. What makes Europa so compelling is the possibility that this ocean is in contact with the Moon's rocky mantle, creating a chemical environment that could support life. Scientists have even observed plumes of water vapor erupting from Europa's surface, suggesting that its ocean may occasionally reach the outside world. Missions like NASA Europa Clipper, set to launch in the next few years, aim to study this moon in unprecedented detail, analyzing its plumes and mapping its ice shell to uncover clues about what lies beneath. Not to be outdone, Enceladus, a small moon of Saturn, has also captured the attention of scientists. Like Europa, it boasts a subsurface ocean, but Enceladus takes it a step further. Its south pole is home to massive geysers that spray water, ice, and organic molecules into space. These plumes were first discovered by the Cassini spacecraft, which flew through them and detected complex organic compounds, including some that are essential for life as we know it. The discovery of hydrothermal vents on Enceladus's ocean floor has only added to the excitement, as these environments on Earth are teeming with microbial life. Future missions could target these plumes, collecting samples to search for signs of life without even needing to land. Then there's Titan, Saturn's largest moon, and one of the most Earth-like worlds in the solar system, albeit in a very alien way. Unlike Europa and Enceladus, Titan has a thick atmosphere and liquid on its surface, but not water. Instead, its rivers, lakes, and seas are filled with liquid methane and ethane. Beneath this icy exterior, however, lies a subsurface ocean of water, making Titan a potential double-ocean world. Its unique chemistry has led some scientists to speculate about the possibility of life forms that use methane instead of water as a solvent. Missions like NASA Dragonfly, a rotorcraft set to launch in the late 2020s, will explore Titan's surface, studying its organic chemistry and searching for clues about probiotic processes that could lead to life. The exploration of these moons isn't just about finding life. It's about understanding the diversity of environments where life could arise. From Europa's salty ocean to Enceladus's hydrothermal vents and Titan's methane seas, each moon offers a unique laboratory for studying the origins and limits of life. And with missions like Europa Clipper, Dragonfly, and others on the horizon, we're on the brink of uncovering answers to questions that have fascinated humanity for centuries. As we peer into the icy depths of these moons, we're reminded that the solar system is far more dynamic and mysterious than we once imagined. But beyond the orbits of Jupiter and Saturn lies an even more distant frontier, one that takes us to the outer reaches of the solar system, where the sun's light fades and the mysteries of the Kuiper Belt and beyond await. What lies in these frozen, uncharted realms? The answers could reshape our understanding of the solar system's history and its future. Beyond the icy moons of Jupiter and Saturn lies a realm that feels almost like a cosmic graveyard, a vast, frozen expanse where the sun's light is little more than a faint glimmer. This is the Kuiper Belt, a region of icy bodies stretching far beyond the orbit of Neptune. Think of it as a distant cousin to the asteroid belt, but instead of rocky fragments, it's filled with frozen relics from the birth of our solar system. These icy objects, some as small as pebbles and others as large as planets, hold secrets that could rewrite our understanding of how the solar system formed and evolved. The Kuiper Belt is more than just a collection of frozen debris. It's a time capsule, preserving materials that have remained virtually unchanged for billions of years. Among its most famous residents is Pluto, once considered the ninth planet and now classified as a dwarf planet. But Pluto is just the tip of the iceberg. The Kuiper Belt is home to countless other objects, including Eris, Makemake, and Haumea, each one a frozen world with its own unique story. These icy bodies are remnants of the early solar system, offering clues about the processes that shaped the planets we know today. One of the most groundbreaking missions to explore this distant frontier is NAS, a New Horizons spacecraft. Launched in 2006, New Horizons made history in 2015 when it flew by Pluto, capturing stunning images of its icy plains, towering mountains, and hazy atmosphere. But the mission didn't stop there. In 2019, New Horizons encountered another Kuiper Belt object, Arrokoth, a snowman-shaped body that provided a glimpse into the solar system's earliest days. Arrokoth's smooth, unblemished surface suggests it formed gently, without the violent collisions that shaped many other objects. This discovery has given scientists new insights into how planetesimals, the building blocks of planets, came together in the early solar system. The Kuiper Belt is also a treasure trove of potential discoveries. Astronomers estimate that thousands of objects remain hidden in this distant region, some of which could be classified as new dwarf planets. These worlds, though small, could hold vital clues about the solar system's history, from the distribution of icy materials to the gravitational interactions that shaped the orbits of the outer planets. But the Kuiper Belt isn't the end of the story. Beyond its icy boundary lies an even more mysterious frontier, the edge of the solar system itself. Here, the sun's influence wanes and the interstellar void begins. What lies in this uncharted territory, and how does it connect our solar system to the wider galaxy? The answers may be closer than we think, waiting to be uncovered as we push further into the unknown. As we venture beyond the Kuiper Belt, we encounter a boundary that marks the edge of the sun's influence, a vast, invisible bubble known as the heliosphere. Imagine the solar system as a ship sailing through the cosmic ocean, with the heliosphere acting as its protective shield. This bubble is created by the solar wind, a stream of charged particles constantly flowing from the sun. It extends far beyond the orbits of the planets, enveloping everything within its reach and shielding us from the harsh radiation of interstellar space. The heliosphere isn't just a static boundary, it's a dynamic region where the solar wind collides with the interstellar medium, the sparse gas and dust that fill the space between stars. This interaction creates a complex zone of turbulence and pressure, like the bow wave of a ship cutting through water. The point where the solar wind slows down and merges with the interstellar medium is called the Heliopause, and it's here that the true nature of our cosmic neighborhood begins to reveal itself. The Voyager probes, launched in the 1970s, have been our pioneers in exploring this frontier. In 2012, Voyager 1 became the first human-made object to cross the Heliopause, entering interstellar space. Its twin, Voyager 2, followed suit in 2018. These historic crossings provided groundbreaking data, revealing that the Heliopause isn't a sharp boundary but a region of transition, where the solar wind gradually gives way to the interstellar medium. What the Voyagers discovered has reshaped our understanding of this cosmic boundary. They detected a higher density of particles in interstellar space than expected, suggesting that the heliosphere compresses the interstellar medium as it moves through the galaxy. They also found that the magnetic field outside the heliosphere is oriented differently than previously thought, challenging our assumptions about the forces that shape this region. Understanding the heliosphere and its interaction with the interstellar medium is more than an academic exercise. It's crucial for the future of interstellar travel. As we dream of sending humans to other stars, we'll need to navigate this boundary safely, shielding ourselves from the intense cosmic radiation that lies beyond. The data from the Voyagers is helping scientists develop models to predict how spacecraft will fare as they cross into interstellar space, paving the way for humanity's first steps beyond the solar system. But the challenges of interstellar exploration don't end at the Heliopause. Beyond this boundary lies a vast and uncharted frontier where distances are measured in light years and the rules of space travel as we know them may no longer apply. What will it take to journey to the stars, and what obstacles must we overcome to make this dream a reality? The answers await us as we explore the next frontier of interstellar exploration. Interstellar travel, the dream of journeying to other star systems, has long captured the human imagination. From science fiction novels to ambitious research projects, the idea of crossing the vast expanse of space to reach distant worlds feels both thrilling and daunting. But what would it actually take to make this dream a reality? The challenges are immense, but so are the possibilities, and the technologies we're developing today could one day take us to the stars. One of the biggest hurdles is distance. The nearest star system, Alpha Centauri, is over 4 light-years away. That means even traveling at the speed of light, something we can't yet achieve, it would take more than 4 years to get there. With current propulsion systems, like chemical rockets, a journey to Alpha Centauri would take tens of thousands of years. Clearly, we need to think outside the box. Enter concepts like light sails, a revolutionary idea that could propel spacecraft using the pressure of light itself. Imagine a giant, ultra-thin sail catching photons from a powerful laser beam. Over time, this gentle push could accelerate a spacecraft to a significant fraction of the speed of light, cutting travel times dramatically. Projects like Breakthrough Starshot are already exploring this concept, aiming to send tiny, lightweight probes to Alpha Centauri within a few decades. While the technology is still in its infancy, the potential is staggering. Another promising avenue is fusion propulsion. By harnessing the power of nuclear fusion, the same process that fuels the sun, we could create engines capable of reaching incredible speeds. Unlike conventional rockets, which rely on chemical reactions, fusion propulsion would generate energy by fusing atomic nuclei, releasing vast amounts of power with minimal fuel. While we haven't yet mastered controlled fusion on Earth, breakthroughs in this field could one day make interstellar travel feasible. Then there's the idea of wormholes, hypothetical tunnels through space-time that could connect distant points in the universe. While this concept remains firmly in the realm of theoretical physics, it offers a tantalizing possibility: shortcuts through the cosmos. If wormholes exist and could be stabilized, they might allow us to traverse vast distances in an instant. Of course, the challenges are monumental, from the energy required to create a wormhole to the mind-bending physics involved. But as we continue to explore the frontiers of science, who knows what discoveries await? Robotic missions could pave the way for these interstellar journeys. Unmanned probes, like those envisioned by Breakthrough Starshot, could be sent ahead to gather data, scout potential destinations, and even prepare the groundwork for human explorers. These missions wouldn't face the same challenges as human travel, such as sustaining life over decades or centuries, making them a practical first step in our journey to the stars. As we contemplate the immense distances and time frames involved in interstellar travel, it's clear that this frontier will require not just technological innovation, but also a rethinking of what it means to explore. And as we push the boundaries of what's possible, another key player is emerging: artificial intelligence. How might AI transform our ability to navigate the cosmos, process vast amounts of data, and even make decisions in the far reaches of space? The next frontier takes us into the evolving role of AI in space exploration, a topic that's as exciting as it is transformative. As we push the boundaries of space exploration, one of the most transformative tools at our disposal is artificial intelligence. AI is no longer confined to science fiction. It's becoming an indispensable partner in our quest to understand the cosmos. From sifting through mountains of data to making split-second decisions on distant worlds, AI is revolutionizing how we explore space, uncovering insights that would be impossible for humans to achieve alone. Take, for example, the sheer volume of data generated by modern space missions. Telescopes like the James Webb Space Telescope and observatories like the Event Horizon Telescope produce terabytes of information every day. Analyzing this data manually would take years, but AI can process it in a fraction of the time, identifying patterns and anomalies that might otherwise go unnoticed. Already, AI algorithms have helped discover new exoplanets, map cosmic structures, and even predict solar storms that could impact Earth. These capabilities are not just about speed. They're about uncovering hidden truths in the vast sea of information that space exploration generates. AI is also transforming how we operate spacecraft. On missions to distant worlds, where communication delays can range from minutes to hours, AI allows spacecraft to make autonomous decisions. NASA Perseverance rover, for instance, uses AI to navigate the rugged terrain of Mars, avoiding obstacles and selecting the best paths without waiting for instructions from Earth. Similarly, AI-powered systems on the International Space Station monitor equipment and predict maintenance needs, ensuring the safety and efficiency of astronauts in orbit. This autonomy is crucial as we venture further into the solar system, where real-time control from Earth becomes impractical, but the potential of AI goes beyond data analysis and automation. It could help us discover entirely new phenomena, from exotic particles to signs of extraterrestrial life. By training AI to recognize patterns that deviate from the norm, scientists can identify unusual signals that might hint at groundbreaking discoveries. For example, AI has already been used to detect fast radio bursts, mysterious, high-energy pulses from deep space, and to analyze the atmospheres of exoplanets for potential biosignatures. These applications highlight how AI isn't just a tool, it's a collaborator, expanding the scope of what we can achieve in space. Of course, the rise of AI in space exploration also raises important ethical questions. How much autonomy should we grant to machines making decisions in environments we can't fully control? What safeguards are needed to ensure AI aligns with human values and priorities? These are complex issues that require careful consideration as we integrate AI more deeply into our missions. Looking ahead, the role of AI in space exploration is only set to grow. From designing more efficient spacecraft to planning missions to distant stars, AI will be at the heart of our efforts to explore the cosmos. But as we embrace this technology, we must also reflect on how our discoveries shape us as a species. How does the act of exploring space change our understanding of ourselves, our planet, and our place in the universe? These questions lead us to the next frontier, where we'll explore the profound impact of space exploration on humanity itself. Space exploration is more than just a scientific endeavor. It's a profound force that has reshaped humanity in ways both tangible and intangible. From the moment we first gazed at the stars to the historic Apollo moon landings and the robotic missions exploring distant worlds, our journey into space has expanded our understanding of the universe and transformed life here on Earth. But the impact goes far beyond the realm of science. It has inspired innovation, fostered international collaboration, and even shifted how we see ourselves in the grand tapestry of existence. One of the most immediate and visible impacts of space exploration is technological advancement. The challenges of sending humans and machines into space have driven breakthroughs in fields ranging from computing to materials science. The miniaturized electronics developed for spacecraft have revolutionized industries, giving us everything from satellite communications to advanced medical imaging. Even everyday items like memory foam, scratch-resistant lenses, and water filtration systems owe their origins to space research. These innovations are a testament to how pushing the boundaries of what's possible in space can create solutions that benefit us all. But the influence of space exploration isn't limited to technology. It has also played a pivotal role in fostering international cooperation. The International Space Station, a marvel of engineering and diplomacy, stands as a symbol of what humanity can achieve when nations work together. Orbiting Earth since the late 1990s, The ISS has hosted astronauts from over 20 countries, conducting experiments that advance our knowledge of biology, physics, and climate science. In a world often divided by borders and ideologies, space exploration offers a rare example of unity, proving that collaboration can transcend political and cultural differences. Beyond science and diplomacy, space exploration has also sparked a cultural and philosophical revolution. The iconic Earthrise photo taken by Apollo 8 astronauts in 1968, a view of our planet rising above the lunar horizon, forever changed how we see ourselves. For the first time, humanity glimpsed Earth not as a collection of nations, but as a fragile, interconnected whole. This perspective, often called the overview effect, has inspired environmental movements, deepened our appreciation for the planet, and highlighted the need to address global challenges like climate change and resource scarcity. Philosophically, space exploration forces us to confront fundamental questions about our place in the universe. Are we alone? What is our purpose? These questions have driven centuries of curiosity, from ancient astronomers to modern scientists. By exploring the cosmos, we not only seek answers but also find new ways to understand ourselves. The quest to explore space is, in many ways, a quest to understand what it means to be human. As we reflect on the profound impact of space exploration, it's clear that this journey is far from over. The next frontier takes us into the future, where new missions, technologies, and ideas will continue to push the boundaries of what's possible. What lies ahead in the evolving story of space exploration, and how might it shape the next chapter of humanity's cosmic journey? The answers await us as we look toward the horizon of discovery. As we stand on the cusp of a new era in space exploration, the possibilities are as vast as the cosmos itself. The next chapter of humanity's journey into the stars is being written right now, fueled by groundbreaking missions, cutting-edge technologies, and unprecedented collaboration between nations and private companies. This is the 23rd frontier, the future of space exploration, a future that's not just about reaching new destinations, but about reshaping how we live, work, and dream beyond Earth. One of the most exciting developments on the horizon is the push to establish a sustainable human presence on the Moon. NASA's Artemis program aims to return astronauts to the lunar surface by the mid-2020s, with the ultimate goal of building a permanent lunar base. This isn't just about planting flags, it's about creating a springboard for deeper space exploration. The Moon's resources, particularly water ice hidden in its shadowed craters, could be harvested to produce oxygen, drinking water, and even rocket fuel. This capability would transform the Moon into a cosmic pit stop, enabling missions to Mars and beyond. But the Moon isn't the only target. Asteroids, those ancient remnants of the early solar system, are also in the spotlight. Companies like Planetary Resources and governmental space agencies are exploring the potential of asteroid mining, extracting valuable metals and minerals from these rocky bodies. Some asteroids contain platinum, nickel, and even rare earth elements, materials that are increasingly scarce on Earth. Mining these celestial bodies could not only support space exploration, but also revolutionize industries back home. Imagine a future where spacecraft act as cosmic prospectors, bringing back resources that fuel technological advancements and economic growth. Meanwhile, the dream of interstellar exploration is inching closer to reality. Projects like Breakthrough Starshot are envisioning tiny, light-powered probes that could travel to Alpha Centauri within a human lifetime. These probes, equipped with cameras and sensors, would send back data from another star system, offering humanity its first glimpse of an alien solar system. While the technology is still in its infancy, the very idea that we're seriously considering such missions is a testament to how far we've come. Private companies are playing an increasingly pivotal role in this new era of exploration. SpaceX, Blue Origin, and other pioneers are pushing the boundaries of what's possible, from reusable rockets to ambitious plans for Mars colonization. These companies are not just supplementing government efforts, they're driving innovation at an unprecedented pace. At the same time, international collaborations, like the European Space Agency's involvement in lunar missions and Japan's contributions to asteroid research, are fostering a spirit of global unity in the quest to explore the cosmos. The future of space exploration is as much about collaboration as it is about competition. By pooling resources, knowledge, and ambition, humanity is on the verge of achieving feats that once seemed like the stuff of science fiction. But as we reach for the stars, we must also consider the ethical implications of our actions. What responsibilities do we have to other worlds, and how do we ensure that our exploration benefits all of humanity? These questions lead us to the next frontier, where we'll explore the moral and ethical dimensions of venturing into the unknown. As we venture further into the cosmos, we're not just exploring new worlds, we're also confronting profound ethical questions. Space exploration, while a triumph of human ingenuity, comes with responsibilities that extend far beyond our own planet. The 24th frontier challenges us to consider the moral implications of our actions. How do we ensure that our quest for discovery doesn't harm other worlds? What obligations do we have to preserve the cosmos for future generations? These questions aren't just philosophical, they are practical, shaping the policies and practices that will guide our journey into the stars. One of the most pressing ethical dilemmas is the risk of contaminating other worlds with Earth-based microbes. Imagine sending a rover to Mars or a probe to Europa, only to discover that it accidentally carried bacteria from Earth, potentially destroying any native life before we even find it. This isn't just a hypothetical concern. It's a real challenge that space agencies like NASA and ESA take seriously. Strict protocols, known as planetary protection measures, are in place to sterilize spacecraft and minimize the risk of contamination. But as missions become more ambitious, balancing the desire to explore with the need to protect becomes increasingly complex. Another ethical issue is the potential exploitation of extraterrestrial resources. Asteroids, for example, are rich in precious metals and rare minerals, sparking interest from both governments and private companies. While mining these resources could revolutionize industries and support space exploration, it also raises questions about ownership and equity. Who has the right to extract and profit from these materials? Should they be considered the heritage of all humanity, or can they be claimed by those with the means to reach them? These questions highlight the need for international agreements, much like the Outer Space Treaty of 1967, which established that space is the province of all mankind. But as technology advances, these treaties may need to evolve to address new challenges. Beyond contamination and resource exploitation, there's also the broader question of how we interact with the cosmos. Space is often seen as a frontier for discovery, but it's also a fragile and ancient environment. Preserving its integrity isn't just about avoiding harm, it's about respecting the universe as a shared heritage. This means thinking beyond short-term gains and considering the long-term impact of our actions. For example, should we terraform Mars to make it habitable for humans, or should we preserve it as a natural environment, even if it means limiting our ability to settle there? These decisions will shape not only our future, but also the legacy we leave for generations to come. The ethical considerations of space exploration are deeply intertwined with our values as a species. They force us to reflect on what kind of explorers we want to be, reckless pioneers or thoughtful stewards of the cosmos. As we grapple with these questions, we're reminded that space exploration isn't just about reaching new destinations, it's about carrying our humanity with us wherever we go. But ethics isn't the only frontier that space exploration opens up. Beyond the practical and moral dilemmas lies a deeper, more philosophical question. What does it mean to explore the universe, and how does this journey change us as individuals and as a species? The answers may lie in the next frontier, where we'll explore the profound philosophical implications of venturing into the cosmos. Space exploration isn't just about rockets, planets, and scientific breakthroughs. It's also a deeply philosophical journey. As we venture into the cosmos, we're confronted with questions that have puzzled humanity for centuries. What is our place in the universe? Are we alone? And what does it mean to exist in a universe so vast and mysterious? These questions don't just challenge our scientific understanding, they challenge our very sense of identity and purpose. At its core, space exploration is an expression of curiosity, a desire to push beyond the boundaries of what we know and seek answers to the unknown. This curiosity has driven some of humanity's greatest achievements, from the first telescopes that revealed the moons of Jupiter to the spacecraft now probing the farthest reaches of our solar system. But it's more than just a quest for knowledge, it's a search for meaning. When we look up at the stars, we're not just observing distant worlds, we're reflecting on our own existence. The universe, with its infinite scale and complexity, forces us to confront the fragility and significance of life on Earth. This sense of awe and wonder isn't just a side effect of space exploration, it's one of its most profound impacts. The famous overview effect, experienced by astronauts who see Earth from space, is a perfect example. From that vantage point, national borders vanish, and our planet appears as a fragile, interconnected whole. This perspective has inspired countless people to think differently about our home, fostering a sense of global unity and environmental stewardship. It's a reminder that space exploration doesn't just expand our understanding of the cosmos, it deepens our understanding of ourselves. But the philosophical implications of space exploration go even further. The search for extraterrestrial life, for instance, raises questions about what it means to be alive. If we discover microbes on Mars or Europa, how will that change our understanding of biology? And if we find intelligent life, how will that reshape our cultural and philosophical frameworks? These possibilities challenge us to think beyond the confines of Earth and consider the broader implications of life in the universe. At the same time, space exploration reminds us of the power of imagination. The stories we tell about the stars, whether through science fiction, mythology, or scientific inquiry, reveal our hopes, fears, and aspirations. They inspire us to dream of a future where humanity reaches beyond its limits, exploring distant worlds and perhaps even finding new homes among the stars. This blend of curiosity, imagination, and ambition is what makes space exploration such a uniquely human endeavor. As we ponder these profound questions, we're reminded that the journey into space is as much about exploring the human spirit as it is about exploring the cosmos. And just as science and philosophy intersect in this quest, so too do art and culture. From the awe-inspiring images captured by telescopes to the music and literature inspired by the stars, humanity's creative expression has always been intertwined with our exploration of the universe. This brings us to the next frontier, the role of art and culture in space exploration, a frontier where creativity and curiosity come together to illuminate the beauty and wonder of the cosmos. Space exploration has always been more than a scientific endeavor. It's a source of inspiration that has ignited the imaginations of artists, writers, and creators across generations. The 26th frontier takes us into the realm of art and culture, where the mysteries of the cosmos have been reimagined through countless creative lenses. From the haunting beauty of sci-fi films to the poetic visions of space in literature, art has played a vital role in shaping how we perceive and connect with the universe. Consider the iconic film 2001, A Space Odyssey, released in 1968. This masterpiece by Stanley Kubrick wasn't just a groundbreaking cinematic achievement, it was a profound meditation on humanity's place in the cosmos. With its stunning visuals, enigmatic narrative, and haunting score, 2001 captured the awe and mystery of space exploration in a way that resonated deeply with audiences. It wasn't just science fiction, it was a cultural touchstone that inspired generations of dreamers to look to the stars. Literature, too, has been profoundly shaped by our fascination with space. From Jules Verne's From the Earth to the Moon to Carl Sagan's Contact, writers have used the cosmos as a canvas to explore themes of discovery, identity, and the unknown. Science fiction, in particular, has often served as a bridge between science and the public imagination, offering visions of the future that challenge us to think beyond the confines of our world. These stories don't just entertain, they inspire, sparking curiosity and wonder about what lies beyond our planet. Artists have also played a crucial role in interpreting scientific discoveries and making them accessible to the public. Take, for example, the golden record aboard the Voyager probes. This collection of sounds, images, and music, curated by a team led by Carl Sagan, was designed to represent Earth to any extraterrestrial beings who might encounter it. But it was also a deeply human endeavor, a creative expression of our culture, diversity, and aspirations. The golden record wasn't just a scientific experiment, it was a work of art, a message in a bottle cast into the cosmic ocean. Even in modern times, artists continue to collaborate with scientists to bring the wonders of space to life. Projects like the Overview Effect, a series of photographs and videos capturing Earth from space, offer a visceral reminder of our planet's fragility and beauty. These works don't just document scientific achievements, they evoke emotions, spark conversations, and inspire action. Art has the unique ability to translate complex ideas into relatable experiences, making the vastness of the cosmos feel personal and immediate. The influence of space exploration on culture is undeniable. It's woven into our music, our films, our literature, and even our daily lives. But this creative exchange isn't just one-sided. Just as science inspires art, art inspires science. The visions of artists and storytellers have often foreshadowed real-world advancements, from space stations to robotic explorers. They remind us that space exploration isn't just about data and technology. It's about dreams, curiosity, and the human spirit. As we celebrate the intersection of art and space, we're reminded that inspiration is a powerful force. It's what drives us to explore, to create, and to imagine what might be possible. But inspiration doesn't happen in a vacuum. It's nurtured through education, through the sharing of knowledge and the fostering of curiosity. And this brings us to the next frontier, the role of education in cultivating a passion for space exploration. How do we inspire the next generation of explorers, scientists, and dreamers? The answers may lie in the lessons we teach and the stories we share. The journey into space isn't just for astronauts and scientists. It's a shared adventure that belongs to all of humanity. The 27th frontier takes us into the realm of space education and outreach, where the wonders of the cosmos are brought to life for people of all ages and backgrounds. Inspiring the next generation of explorers, thinkers, and dreamers is essential to the future of space exploration, and it's a mission that begins long before anyone steps foot on a rocket. One of the most exciting ways to ignite this passion is through space camps and hands-on programs. Places like NASA, a space camp in Alabama, and similar programs around the world offer young people the chance to experience the thrill of space exploration firsthand. From building model rockets to simulating lunar missions, these immersive experiences spark curiosity and creativity, showing participants that the stars aren't out of reach. It's not just about learning facts, it's about fostering a sense of wonder and possibility that can last a lifetime. But education doesn't stop at camps. Citizen science projects have opened up space exploration to everyone, regardless of age or expertise. Platforms like Zooniverse allow anyone to contribute to real scientific research, from classifying galaxies to searching for exoplanets. These projects democratize science, showing that you don't need a PhD to make a meaningful contribution. They also remind us that space exploration is a collective effort, one that thrives on the passion and curiosity of people from all walks of life. Public outreach programs, often led by space agencies and universities, play a crucial role in making space accessible. Events like Astronomy on Tap and public telescope nights bring the cosmos closer to home, offering people the chance to gaze at the stars and learn from experts. These gatherings aren't just educational, they are communal, creating spaces where people can share their excitement and ask questions in a welcoming environment. Social media has also transformed how we engage with space. Platforms like Twitter, Instagram, and YouTube have become hubs for sharing stunning images, breaking news, and behind-the-scenes glimpses of missions. Astronauts like Chris Hadfield and Scott Kelly have used social media to connect with millions, offering a personal perspective on life in space. Documentaries and series, such as Cosmos and The Farthest, have brought the stories of space exploration to living rooms around the world, making complex ideas relatable and inspiring. The impact of these efforts goes beyond inspiring future scientists and engineers. They shape how we see ourselves in the universe. By making space exploration accessible, we're fostering a sense of shared curiosity and responsibility. After all, the journey to the stars isn't just about discovery, it's about connection. As we look to the future, it's clear that the next generation will play a pivotal role in shaping the course of space exploration. But they won't be alone. In the next frontier, we'll explore how everyday people, citizen scientists, are contributing to our understanding of the cosmos, proving that the stars belong to us all. Space exploration has long been seen as the domain of professional scientists and engineers, but the 28th frontier is reshaping that narrative. Citizen science, the involvement of everyday people in scientific research, has become a powerful force in our quest to understand the cosmos. From classifying galaxies to spotting distant planets, ordinary individuals are now contributing to discoveries that once seemed the exclusive realm of experts. This democratization of science is not just expanding our knowledge, it's redefining who gets to participate in the grand adventure of exploring the universe. One of the most iconic examples of citizen science in action is Galaxy Zoo. Launched in 2007, This project invites volunteers to classify galaxies based on images captured by telescopes. With millions of galaxies to analyze, professional astronomers simply couldn't handle the workload alone. Enter the public. Over the years, hundreds of thousands of people have contributed their time and curiosity, helping scientists catalog galaxies and uncover rare phenomena, such as galaxy mergers and unusual star formations. This collaborative effort has led to dozens of scientific papers and even the discovery of entirely new types of celestial objects. It's a testament to what can be achieved when curiosity meets collective effort. Another groundbreaking initiative is Planet Hunters, a project that enlists volunteers to sift through data from NASA Kepler and TESS missions. By examining the light curves of distant stars, participants can identify subtle dips in brightness that might indicate the presence of an orbiting planet. This method has proven remarkably effective. Citizen scientists have discovered numerous exoplanets, including some in the habitable zones of their stars. These discoveries not only advance our understanding of planetary systems, but also highlight the potential of public participation in cutting-edge research. The impact of citizen science goes beyond individual discoveries. It fosters a sense of ownership and connection to the cosmos, empowering people to contribute to humanity's collective knowledge. Projects like these also challenge the traditional boundaries of science, showing that expertise isn't confined to labs or universities. It can come from anyone with curiosity and a willingness to learn. This inclusive approach is transforming how we explore the universe, making space a shared frontier for all. But the role of citizen science isn't just about analyzing data or making discoveries. It's also about building bridges between the scientific community and the public. By engaging people in real research, these projects inspire a deeper appreciation for the scientific process and the wonders of the cosmos. They remind us that space exploration isn't just about reaching distant worlds, it's about bringing people together in pursuit of knowledge. As we celebrate the contributions of citizen scientists, we're reminded that space exploration is a collective endeavor, one that thrives on the curiosity and passion of people from all walks of life. And while the stars may seem distant, the next frontier brings us back to Earth, where space exploration is playing a crucial role in addressing some of our planet's most pressing challenges. From climate monitoring to disaster response, the tools and technologies developed for space are helping us tackle global issues in ways we never imagined. Space exploration has always been about reaching beyond our world, but its impact isn't confined to the stars. The 29th frontier takes us back to Earth, where the tools and technologies developed for space are helping tackle some of our planet's most pressing challenges. From monitoring climate change to managing natural disasters, the innovations born from our quest to explore the cosmos are proving to be invaluable in addressing global issues. Take climate change, for example. Satellites orbiting Earth are some of our most powerful tools for understanding and combating this crisis. Instruments designed to measure atmospheric composition, track ice melt, and monitor deforestation provide critical data that helps scientists predict changes and policymakers make informed decisions. The European Space Agency's Copernicus program, for instance, delivers real-time information on everything from air quality to sea level rise, empowering nations to take action. These technologies, originally developed for space exploration, are now at the forefront of the fight to protect our planet. Resource scarcity is another challenge where space technology is making a difference. Advanced imaging systems used to map distant planets are being repurposed to locate underground water sources and monitor agricultural land. In regions struggling with drought, these tools are helping communities manage water resources more efficiently, ensuring food security and sustainability. Similarly, the development of closed-loop life support systems for long-duration space missions is inspiring innovations in recycling and resource management on Earth, offering solutions to waste and energy challenges. Disaster management is yet another area where space exploration shines. Satellites equipped with high-resolution cameras and radar systems can quickly assess damage after natural disasters like earthquakes, hurricanes, or wildfires. This information is crucial for coordinating rescue efforts, allocating resources, and rebuilding communities. For instance, during the devastating floods in Pakistan in 2022, satellite data provided by international space agencies helped identify the hardest-hit areas, guiding relief efforts and saving lives. What makes these solutions even more powerful is the potential for international cooperation. Space exploration has a unique ability to bring nations together, transcending borders and political differences. Initiatives like the International Space Station demonstrate how collaboration can achieve extraordinary results, and this spirit of unity is equally vital in addressing global challenges. Whether it's sharing satellite data to track deforestation or pooling resources to develop sustainable technologies, space exploration reminds us that the challenges we face are not confined to one country. They are shared by all of humanity. As we harness the tools of space exploration to solve Earth's problems, we're reminded that the cosmos isn't just a destination. It's a source of inspiration and innovation that can improve life here on Earth. But even as we look to the stars for solutions, there's one frontier that remains constant: the enduring allure of space itself. What is it about the cosmos that continues to captivate us, generation after generation? The answer lies in the final frontier, where we'll reflect on the timeless fascination that drives us to explore the unknown. The 30th and final frontier brings us full circle, back to the very essence of why we explore, the enduring allure of space itself. What is it about the cosmos that captures our imagination so profoundly, generation after generation? Perhaps it's the sheer vastness of the universe, a canvas of infinite possibilities that invites us to dream beyond the limits of our world. Or maybe it's the innate human curiosity that drives us to ask questions, to seek answers, and to push the boundaries of what we know. Space exploration isn't just a scientific endeavor, it's a testament to our collective spirit, a reflection of our deepest hopes and aspirations. At its core, this fascination with the stars is rooted in something universal: the desire to discover. From the earliest stargazers who mapped constellations to the modern astronauts who walk on other worlds, humanity has always been drawn to the unknown. This isn't just about solving mysteries, it's about expanding our understanding of who we are and where we fit in the grand tapestry of existence. Every mission, every discovery, is a step toward answering the profound questions that have shaped our species for millennia. But the allure of space exploration goes even deeper. It's a unifying force, a shared endeavor that transcends borders, cultures, and ideologies. When we launch a spacecraft or land a rover on another planet, we're not just representing a single nation, we're representing humanity as a whole. The iconic image of Earth rising above the lunar horizon, captured by Apollo 8, didn't just inspire awe, it reminded us that we're all passengers on the same fragile planet, bound together by a common destiny. Space exploration also offers something else: hope. In a world often divided by conflict and uncertainty, The quest to explore the cosmos reminds us of what we can achieve when we work together. It's a beacon of possibility, a reminder that no challenge is too great when we unite in pursuit of a shared goal. Whether it's building a sustainable colony on Mars or sending probes to distant stars, these endeavors inspire us to imagine a future where humanity thrives, not just on Earth but among the stars. This journey through the 30 cosmic frontiers has taken us from the icy fringes of the solar system to the vast expanse of interstellar space, from the birth of stars to the mysteries of black holes. We've explored the search for life, the promise of new technologies, and the ethical questions that come with venturing into the unknown. Each frontier has revealed new wonders, new challenges, and new opportunities, reminding us that the universe is as boundless as our curiosity. As we conclude this exploration, we're reminded that space isn't just a destination, it's a journey. It's a journey that unites us, inspires us, and challenges us to reach beyond our limits. The allure of space exploration lies not just in the discoveries we've made, but in the promise of what's yet to come. And as long as we keep looking up, asking questions, and dreaming of the stars, that journey will never end. So, what's next? The answer lies not just in the frontiers we've explored, but in the ones we've yet to imagine. The cosmos is vast, and the possibilities are endless. The story of space exploration is far from over. It's just beginning, and as we turn the page to the next chapter, one thing is certain: the stars will always be there, waiting for us to take the